Namaste children. Today in this session number 33 we are going to solve the problems from brain teasers second main. Question number 2, state whether the following statements are true or false. If false, justify your answer with an example. The first statement is, if absolute value of x is equal to 0, then x has no reciprocal. As we know, if absolute value of x is 0 children, then x will be 0, because we have to neglect the sign, negative sign, and write the same rational number. Here the rational number is x, so modulus of x is equal to 0. Therefore absolute value of x means x it is, x is also 0. But do we have reciprocal for 0? No, there is no reciprocal, that is, but 0 has no reciprocal. Therefore we write the answer as false and then we will justify the answer, but 0 has no reciprocal. Question number 2, if x is less than y, then absolute value of x is less than absolute value of y. Here let us take the values of x and y as x equal to minus 3 and y is equal to minus 2. Both the rational numbers we have taken as negative. Now here minus 3, x is minus 3 and y is minus 2. We know x minus 3 is less than minus 2, that is x is less than y. Now let us find the absolute value of x here. What is the value of x we have taken? Minus 3. Absolute value of minus 3 is equal to 3. We have to neglect the negative sign and write the same rational number. Absolute value of y, that is absolute value of minus 2, which is equal to 2. Now we have got the value of absolute value of x as 3 and absolute value of y as 2. We observe here 3 is greater than 2, that is absolute value of x is greater than absolute value of y, but in the statement we have got absolute value of x is less than absolute value of y. Therefore we write the statement as false and this is the justification. Question number 3, if x is less than y and then x inverse is less than y inverse. Here also let us assume x is equal to 2 and y is equal to 3. What is x inverse? X inverse is, we have to take the same rational number. 2 is nothing but 2 by 1. 2 by 1 whole inverse, which is equal to, we have to change the numerator and denominator to write the reciprocal. 1 by 2 is the value of x inverse. Now let us find the value of y inverse. Y inverse is equal to 3 means 3 by 1 whole inverse, which is equal to 1 by 3. Now let us compare what is 1 by 2 and 1 by 3. Children, here to compare 1 by 2 and 1 by 3, we know we are going to cross multiply. 1 3s are 3, 2 1s are 2. Here 3 is greater than 2. As we know, 3 is, that is x inverse, and 2 is y inverse. So x inverse is greater than y inverse. Here in the statement we have x inverse is less than y inverse, which is false. Question number 4, the negative of a negative rational number is a positive rational number. Let us take a negative rational number, that is minus 2 by 7, and the negative of this again. So minus into minus is plus 2 by 7. Negative of a negative rational number is positive. So we get the positive rational number. We write the statement as true. Product of two rational numbers can never be an integer. Here always we get an integer. Let us see how. If I take any two rational numbers, 2 by 3 into 3 by 2, what we get here? we cancel 3 ones are 3 ones are, and then 2 ones are 2 ones are. We get 1, which is an integer. Here we have got an integer, so the statement is false. Here it is given can never be an integer, but we have got an integer in this case, so we write false. Product of two integers is never a fraction. Children, let us take two integers here. Product of two integers means we have to multiply two integers. One is -1 and the other is 2. Two integers we have taken. -1 into 2, which is equal to -2. Here we get -2, which is again an integer. So the answer is true. Question number 7. If x and y are two integers, if x and y are two rational numbers such that x is greater than y, then x minus y is always a positive rational number. Always, children, we have to take the values of x and y and then verify the statement. Let us take x is equal to 5 and y is equal to 2. Here we have to take x and y as the rational numbers. So 5 by 1 and 2 by 1 we have taken, such that x is greater than y. Here we can observe 5 is greater than 2. Then we have to find x minus y. What is x minus y, children? 5 minus 2, which is 3. So is 3 positive rational number? Yes, it is always a positive rational number because we know x is greater than y here in this case. So the answer is, the statement is true. Next is question number 3. For x equal to 3 by 4 and y is equal to minus 9 by 8, insert a rational number between. These type of questions we have already solved, children. But here we have to find the x plus y inverse separately and x inverse plus y inverse separately. So what we get here, in place of x we have to substitute 3 by 4 plus y value is minus 9 by 8. Here, before doing or writing the reciprocal of these numbers, inside numbers has to be solved first. The LCM for 4 and 8 is 8. 4 2s are 8. 8 1s are 8. Now 3 2s are 6. Plus into minus is minus. 9 1s are 9. 6 minus 9 is minus 3 by 8 whole inverse. Now the reciprocal of minus 3 by 8 is minus 8 by 3. Now let us consider x inverse plus y inverse. In place of x we have to substitute 3 by 4 plus whole inverse plus minus 9 by 8 y inverse in place of y inverse. Now first let us separately write the reciprocal. 3 by 4 reciprocal is 4 by 3, minus 9 by 8 reciprocal is minus 8 by 9. Now find the LCM for 3 and 9, which is 9. 3 3s are 9 and then 9 1s are 9. 4 3s are 12 minus 8 1s are 8. 12 minus 8 is 4 by 9. Now between these two rational numbers, that is minus 8 by 3 and 4 by 9, we have to find a rational number. We know the formula is, if this is x and this is y, how do we find out the rational number between two rational numbers, children? 1 by 2 into x plus y. Here x is minus 8 by 3 and y is 4 by 9. 1 by 2 into minus 8 by 3 plus 4 by 9. Let us solve inside the brackets. LCM is 9. 3 3s are 9. 1s are minus 8 into 3 is minus 24 plus 4 1s are 4. Minus 24 plus 4 is minus 20. 1 by 2 into as it is divided by 9. Cancellation, children. 2 1s are 2 10s are. Minus 10 by 9 is the rational number between minus 8 by 3 and 4 by 9. Question number 2. X minus y whole inverse and x inverse minus y inverse. First let us find the value of these, that is 3 by 4 minus minus 9 by 8 whole inverse. Here the x and y values are given, children. Same we are going to substitute. LCM is 8. 4 2s are 8 and then 8 1s are 8. 3 2s are 6, minus into minus is plus, 9 1s are 9. 9 plus 6 is 15, and then 15 by 8 whole inverse. The reciprocal of 15 by 8 is 8 by 15. Now let us find x inverse minus y inverse. 3 by 4 whole inverse minus of minus 9 by 8 whole inverse. Reciprocal of 3 by 4 is 4 by 3 minus 8 by 9 is the reciprocal of minus 9 by 8. Now LCM is 9. 3 3s are 9. 9 1s are 9. 4 3s are 12. Minus into minus is plus. 8 1s are 8. 12 plus 8 is 20 by 9. Now let us find the rational number between 8 by 15 and 20 by 9. 1 by 2 into the two rational number. We have to add the two rational numbers. 1 by 2 into LCM for 15 and 9 is 45. 15 3s are 45, and then 9 5s are 45. 8 3s are 24 plus 20 5s are 100. 100 plus 24 is 124 by 45 into 1 by 2. No cancellation between 124 and 45, but here outside 1 by 2 is there. 2 1s are, 2 6 are, 2 2s are. 62 divided by 45 is the rational number between 8 by 15 and 20 by 9. Next is question number 4. Verify that x divided by whole inverse is equal to x inverse divided by y inverse by taking x value and y value. Let us consider only the LHS, children. In place of x I write minus 5 by 11 divided by y value is 7 by 3 whole inverse, which is equal to minus 5 by 11. Convert division sign to multiplication sign and write the reciprocal of the second rational number. 7 by 3 is 3 by 7 whole inverse. Cancellation is not possible. Multiply minus 5 into 3 is minus 15. 11 7s are 77 whole inverse. Now reciprocal of minus 15 by 77 is minus 77 by 15. Now consider RHS. X inverse divided by y inverse. Minus 5 by 11 whole inverse divided by 7 by 3 whole inverse. Reciprocal of minus 5 by 11 is minus 11 by 5 divided by 3 by 7. Minus 11 by 5 into 7 by 3 again, because division sign is there. Write the reciprocal of the second rational number. Now minus 11 into 7 is 77 divided by 5 3s are 15. We have verified LHS is equal to RHS, hence verified. Question number 5. Verify that modulus of x plus y is less than or equal to modulus of x plus modulus of y by taking the values of x and y. Consider LHS equal to absolute value of x plus y. X value is 2 by 3 plus minus 3 by 5 is the value of y. Now find the LCM. 3 and 5 LCM is 15. 3 5s are 15, and then 5 3s are 15. 5 2s are 10 minus 3 3s are 9. 10 minus 9 is 1 by 15. Absolute value of 1 by 15 is 1 by 15 again. RHS is equal to absolute value of x plus absolute value of y. 2 by 3 plus of minus 3 by 5. First find the absolute value separately. 2 by 3 plus absolute value of minus 3 by 5 is 3 by 5, neglecting the negative sign. Now LCM is 15. 3 5s are 15. 5 3s are 15. 2 5s are 10 plus 3 3s are 9. 10 plus 9 is 19 by 15. Here we find LHS is less than or equal to RHS, that is 1 by 15 is less than 19 by 15. Therefore, we have verified LHS is less than RHS. Children, in this session we have solved the problems from brain teasers. Question number 2, under that true or false, and then question number 3, question number 4, question number 5. Hope you have understood well, children. Thank you, children.